potential energy function for the force between two atoms in a diatomic molecule is given by ux. U at any point x will be equal to a by x raised to power of 12 minus b by x raised to power of 6, right, where a and b are constants and x is the distance between the atoms. If the dissociation energy of the molecule is d, and d, the formula is given u at infinity minus u at equilibrium, right? Then d is, what is d? So basically we're talking about equilibrium, energy at equilibrium, and energy when, potential energy when x equal to infinity. When we know that if I put x equal to infinity, it will be equal to what? 0, because this will be infinity, this will be infinity, and denominator it is infinity, so that means it will be 0. Now we have to calculate u at equilibrium. For that, first of all, we require what is equilibrium. When do we get equilibrium? Equilibrium is a point when f is 0, right? And from the formula of potential energy, I can calculate f is minus du by dx. I can write this. So that means this I can write it as minus of 12a by x raised to power of 13 plus 6b by x raised to power of 7. Sorry, this will be basically minus, right? So now this should be equal to 0. Now for this to be equal to 0, that means 12a divided by x raised to power of 13 should be equal to 6b by x raised to power 7, or I can write it as that x raised to power of 6 will be equal to 2a by b, right? Now this I can mark, and this I can put in this ux, and I can get the value of x at equilibrium, right? So this will be a divided by of 4a by 4a square by b square minus b divided by 2a by b, or I can write it as b square divided by of 4a minus b by 2a, or I can write it as minus b by 4a, right? B square by 4a, sorry. So that means if I have to calculate the value of d, u at infinity was 0, so that means 0 minus of minus b square by 4a, or I can write it as b square by 4a, right? So this is the answer. That means option C is correct. So this was a relatively good question, but it involved the concept of equilibrium, which says that f is 0. So wherever you see equilibrium in the question, just use this condition, f equal to 0, right?